Okay, so we are at our Hilltop Aarow project. Like I said, this is a house that our firm, Aarow Building, is building with Stephen Basic. Steve was in charge of the design on this house. We had some input. We talked about assembly with him. Choices were made. And one of the things that we think about when we're designing a house is the 4 control layers. So if you remember last week's video or any other time you've heard me talk about control layers, we are talking first about water management. If the building gets wet constantly and it causes damage, then we have a problem. Number 2, we are talking about air management. If we have air leaking through the assembly, we have issues. Number 3, we are talking about thermal. And number 4, we are worried about vapor control. And again, just like last week, the reason we put those in that order is because vapor is the least important and bulk water is the most important. If every time it rains, water runs down inside your wall and comes out onto the floor inside your house, not only is that the first instance for your available for your clients to be really pissed, deservedly so, but it also is going to cause damage eventually. And we are least likely to have a vapor issue. So I thought what we would do is we would look at the plans today and talk about the vapor profile of our wall. So let's reiterate one more time. We are going to air seal to stop moist air running through our walls. We are going to raise the temperature of our assembly as much as possible, and an easy way to do that is exterior insulation so that dew point or condensation point takes place outside of our assembly. And then we are going to dehumidify the interior of the building. So the dehumidify is not on the plans we're going to look at. And then we'll circle back around at the end. There's actually a 4th method that we are going to use to limit the possibility of vapor damage in our walls. So the choices that were made here take all of those things into play, and we consider our climate zone. If we were in northern Canada, we probably would be building something different. And if we were in, Houston, Texas, we probably would be slightly different. So this is climate zone 4. We are a heating dominated climate, but just by a little bit. So let's look at the choices that Steve and I made and the decisions that we made, and let's talk about each part of the assembly and why it works and what it has to do with vapor. Okay, so let's look at the building in section, and for simplicity, we're going to talk exclusively about the wall section, but understand that the roof or the cantilever floor that I'm sitting in right now are still just variations of what we have in this section. There might be different things doing different jobs, or there might be the same things in different orientations doing different jobs, or the same job. So I thought it would be easiest if we started on the outside and worked our way in. And if you watch Steve's videos here on the Build Show Network, you know he uses Big Red. So I brought Mr. Pink today so that we could highlight things and follow our discussion. So let's start with simplicity. We are missing item number 1, which is our cladding. And so that's the first method that we deal with moisture in the walls, which is a bulk water issue. But it's important to note that from there in, we're still dealing with bulk water or vapor, or potentially both. So when we start and we have a rain screen on the outside, and I think it's important that we note that in this conversation because it increases drying potential, which then makes our air control layer and our water control layer more effective. So that air and water control layer that's on the outside is our zip sheathing. And if I would have just said zip sheathing, then we would be talking about air and water. But because we have zip R9, I actually have exterior insulation. And so our R value of our wall is somewhere around R32. And that's not counting our glazing, that's just the opaque sections of the wall. But if we have R9, then we have about 30% of that insulation on the outside, which is the rule of thumb number for put a certain amount to the outside in order to warm that cavity the most. And now we have helped with the dew point in the wall by pushing it further out, pushing it further towards the exterior and away from the things like our framing that could be bothered by that. So our zip sheathing is managing for air, water, and vapor on some level, as well as thermal. So you have one system, one manufacturer, and it gets 4 credits in this control layers assembly. Note, off the topic of what we're talking about, I love this about Steve. Roll the tapes, wipe the area clean, roll the tape, and go ahead and shingle everything so it sheds water. This is I'm paying attention to my job as an architect spec that I think is fantastic. I've seen before where it says install per manufacturer's installation methods, but there's no arguing with this if your framers are on site. Next, we have our structural component, which happens to be our T-studs in the assembly. If you haven't seen the T-stud before, we have a couple videos about that. You can go back and watch. Steve also has a couple videos. But just understand that it's basically a Larson truss with a 1.5 inch plate on one side and a 2 1/4 plate on the other side. And they're oriented in opposite directions so that we get optimal structural integrity out of it. But because they're a truss, they have these voids. And those voids allow for insulation, which cuts down on the amount of thermal bridging from in to out or out to in on our assembly, as well as the Zip R does. But when we reduce that thermal bridging, this Zip R performs at a much better value. And now we again have raised the temperature of this center section of the wall. From there we have so we have our T-stud. From there we have an R21 blown in insulation. In this instance we actually used a blown in place wool, natural wool. It's from Havelock. We didn't know what the final decision was going to be when we cross-sectioned the wall for these drawings. That's why it says blown. But we get about an R4.3 per inch out of that insulation. And then because of the T-studs, we also get insulation in those areas. So we have our thermal control layer that's helping to raise the temperature of the wall and push that dew point out to where it won't matter. Next, as you can see here, we have 1/2 inch gypsum wallboard. And this is a very standard assembly if you cover over the Zip R and we go to a regular stud in our market, that 1/2 inch gypsum. So there was a time that we would have placed poly sheathing on the inside, 6 mil poly, and we would have taped the seams. In reality, we were probably making a mistake because we were adding a air control layer there and not a vapor control layer like we thought. We were doing a really poor job of adding an air control layer, and that's why it worked for vapor. But that causes some issues. If we put poly on the inside of that drywall, or for that matter, vinyl wallpaper on the outside of that drywall, we now have a non-vapor permeable membrane with the polyiso on the sheathing, which would be here, and we have a non-vapor permeable layer there or here, whether it's the poly or the wallpaper. And so then we have a problem of what happens if something gets in. There's no drying potential this way, there's no drying potential that way. We have to understand the vapor profile of this wall. So there is a missing item right here. So let's go to page number 2. The same assembly, but we've added one thing. We've added this smart vapor retarder, or intelligent, the way I like to think of it, vapor retarder in the Siga Myrex. So now we have non-vapor permeable layer here in the polyiso, which means we have to dry from the polyiso in and we have to dry from the polyiso out. We have good drying potential this direction because we have the rain screen and our cladding, and we're ventilating the face of this, think of it as OSB, the zip sheathing. And from that polyiso this direction, we have great drying potential. But when we have good drying potential, we also have good wetting potential, and that's where our problem comes in. If moisture can get out of the wall in this method, moisture could get into the wall. And so we have to be concerned with vapor movement. But again, we solve for air, we raise the temperature, and then we control interior conditions. So those three things help, but if we're going for a belt and suspenders approach, we're going to add right here the Siga Myrex. And the Siga Myrex could be an air barrier and a vapor barrier, or it could be just a vapor barrier. In our instance, we're just using it as a vapor barrier, so we're not terribly concerned with the way that we're taping the seams. And the reason for that is vapor is a uniform load as opposed to a point load. The uniform load is set over the entire assembly. And if we have equal pressure over the entire assembly and we have one hole in the assembly, then things will leak through that one hole if they're very close to that one hole or if they're located at that one hole. Air, on the other hand, is a point load. So if we have equal pressure over the entire assembly and we have one hole, the entire assembly funnels to that one hole. So if you have a vapor retarder that laps, you might have a little bit of a hit at that lap, but what you don't have is a hit for the entire assembly. So everywhere that you don't have a lap, you don't have a seam that didn't get taped or anything like that, you have a really good vapor barrier still. So one of the things that we will do is that we will pay very close attention. We will follow the manufacturer's recommendation for install, and if we have enough time left in the budget and time left in our schedule, then we will also go ahead and tape all of the seams, and then we have kind of an air control layer and a vapor control layer in one, and that makes the product just that much better. Here, we're mostly worried about this from a vapor standpoint, because without this project, we're gonna be 0.6 ACH50, and when you get to that low of a number, we're not concerned with the air moving through the wall. Our air barrier is out at the face of our sheathing, and it makes things very simple for us to just keep it out at that elevation. So how does this vapor retarder that is a film product, a sheet product, a roll good, not the same thing as the vinyl wallpaper that we said or the poly sheathing? Well, this product will allow no moisture migration through the wall from basically the easiest way to look at it is the printed side into the wall, but it will allow vapor to migrate from the wall out. I can say science, that's the easiest way to explain it. It's science. The product is sensitive in one direction and not in the other, and it actually varies. So the more moisture that winds up in the wall, the more it opens up to let things out. But it is a unidirectional product. So as long as you put it on with the words facing you, it will dry from in the wall outward. So now, this vapor profile that I drew before, where we're drawing from the wall out and from the polyiso out, is still maintained. The only thing is, we eliminated the ability for things to drive into the wall. So effectively, we've taken what is a pretty decent wall, a pretty good wall, and added one simple product that's very effective to make it a great wall, because now we've done a better job of reducing the risk of things getting into the wall. So the last couple things after we have this vapor retarder that we've talked about, the increased drying potential, that's what that provides us. Dehumidifying the building, that comes down to greatly educating your clients and having a mechanical system that's right sized so that in the times of the year that it does need to dehumidify, it takes care of it. And they're aware of what you're doing. And then forbidding them from putting vinyl wallpaper on the inside of the wall, because that vinyl wallpaper is the same as putting poly sheething or polyplastic on the inside face of the wall. So I hope that this clears up vapor in your wall. This is not applied evenly across every climate zone. This is applied to our climate zone, and the ideas here apply mostly to other assemblies and other markets. But think about what you're doing, think about vapor in the wall, and think about handling vapor with smart vapor retarder, good air sealing, and doing a really good job of warming the assembly so that we don't have to worry about dew point being inside the wall. And I think you have an opportunity for success here. Thanks for watching the Build Show this week. Don't forget, if you didn't watch it already, go back and check out last week's video about the same topic, but in theory, this is how vapor works. Don't forget to subscribe to the newsletter. You get an email every Friday morning from Mr. Reisinger showing you all the cool stuff that Steve Basic, Brent Hall, Wade Paquin, myself, and Matt have put up. There is a lot of good learning taking place. And again, don't forget that I co-host a podcast with Steve Basic and our friend Peter Yost on building and building science. And we have more than a couple hours worth of content on vapor and building assemblies that are very educational and a good listen, if I do say so myself. Thanks for watching. Follow me on Instagram, jake.bruton. Till next time, consider how you build.